Okay, so we're more than halfway through. We are at slide 119 of 189. So let's power through this. We got like 49% on our GIM kit, so we got some work to do there. So hopefully the stuff that we talk about now will make the GIM kit even easier. That GIM kit is 39 questions. We're used to having like 10 questions and repeating it over and over. So we're stretching a little bit, okay? So it'll be whole chapters from here on out. PC networking tools. Okay, so this is the common networking toolkit that you have. If you look behind us, up on the shelves, the orange and black cases, those are for you guys to use. There should be enough for everybody, but we can also share, and I also have miscellaneous tools in the toolbox over here to my left as well. So a couple of the things to kind of take note of inside our little toolkit here. Starting on the left-hand side, it's kind of hard to see, but you'll have a pair of either, some of them have pliers, other ones have like wire strippers. This is if you notice, it's a long-handled or a long, I don't know, it's just a longer than normal screw head, Phillips head. So why do you think that's good to have in your PC toolkit? Yeah, so the motherboards sit all the way down and then the case kind of comes up. So this allows you to kind of stay on top of them. You're not trying to like get in there and like, there's been many times where I've just sliced my knuckles like around a power supply or a like a CPU cooler. So that'll help you to get at the motherboard. Pair of pliers. They also, if you notice, they have the wire cutters in the center there. This thing right here is a pair of tweezers. So they'll either have tweezers or they'll have like a three-pronged like tool extractor or a screw extractor. So why do you think we need that? Yeah, so as you're, unscrewing the motherboard and it falls underneath the motherboard or gets to a place that's hard to get to, like between the cooler and the CPU, that's good because you can press the plunger on the top, put it on top of the screw and let go, and it'll be attached to your little three-prong tool. Over here we have our ESD strap. We talked about that yesterday, so we don't fry our components. And then the rest of these are attachments for our screwdriver and our Allen keys. You'll also notice there is a little pillbox looking thing down here for any extra screws, because almost every time you take something apart, you probably put it back together better than the manufacturer does, and you find extra screws. So hold on to those screws so that way if you need them in the future. ESD strap, we know what that's for. Our screwdriver, our pliers. This is the extension magnet. So I'm personally not a fan of these because what are cases made out of? Metal. And are magnets good for spinning disk hard drives? No. So if you don't know how a hard drive works, it's like a record player and there's this little arm that goes back and forth and it uses magnets in order to save data. So if we're using magnets inside of computers, we have there's a higher likelihood that we could potentially ruin it. You don't really see spinning disk hard drives that much anymore unless it's a very inexpensive computer, but for servers and stuff, we still use those spinning disk drives. The little three-prong tool that I told you about, that's what it looks like. Note the plunger where you press on the back, and then these little three prongs extend out, so you can put it on the screw and extract it out of the computer. Multimeter. So we'll probably do some soldering and multimeter and electronics all as a whole. I have a guy come in. His name is Josh Hildebrand. He runs an IT company in town, but he is a electronics wizard. I bought a electric skateboard like 5 years ago, and I took him on it because I had bought two, and then he started building his own, and then kind of created a business out of that, making parts for one wheels and building electronic skateboards. So he'll probably bring it in. We'll take some cruises around the school on the electric skateboard, maybe some races, and we can learn about electronics. But multimeters just test our voltage, amperage, or resistance for electrical components. In my 15-year career, the only time I've really used multimeters is for either testing power supplies, but there's a better option, and like working on cars. You don't really use them very much in like regular IT. But now if you're working in a factory and you're working on machines and you're also responsible for those, chances are you're going to need to know how to use a multimeter. This is the power supply tester. You guys all had these. If you remember, they were in little green packages on your desk. Basically, you plug in the power supply and it gives you a readout of how much voltage is coming through, so you can see if your power supply is bad. That's a lot safer than using the paperclip method as far as like plugging in a paperclip to try to get the computer or the power supply to kick on to see if it's a good power supply. This is a much safer way to do it. Tone generator. So these are pretty cool. These are also called Fox and Hounds. So let's say, like, if we look up towards that rack at the back of the classroom, there's all these wires that go up into the ceiling and who knows where they go. So what you can do is you can attach one side and it's going to send out a pulse, like a tone. So it's going to be like beep, 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 beep. And then this right here is like a little, let me try my laser pointer. This little section right here you put on the outside of the cable, and you can see on the other end where that is actually coming from, where that tone's coming from. So you just touch the outside of the network cable, and then it'll start making beeping sounds. So that way you can identify at the far end where it's at, because a lot of times people forget to mark what cables do. So this is a way that you can kind of find, or even if you put it up to an outlet, you'll be able to see where the wire goes to on the other end. So it's a very useful tool to have. So you can see here it's directly plugged into that jack, and then we can go to the other end of it and see what pair starts making sounds. We'll also, when we make networking cable, you guys are gonna hate your life for those probably 2 days. It's one of the least favorite things of students to do, but we use this cable tester to make sure that all of our pins are lined up where they need to be to make sure that data can flow through, okay? Loop back plugs. So have you ever had a teacher like teach you something and then have you tell it back to them? Like a teach back almost? That's what a loop back plug does. So we can plug this into a cable and see if we're getting a signal back through, just to see if it's alive. Okay, so loop back plugs are used for diagnosing. Okay, so another way to work on computers is just to having some known good spares on the shelf as an easy, quick like parts change to see if something is working properly. Okay, does that make sense? Awesome. So troubleshooting process. This is what you guys need to pay attention to. Write it down. This is something that is in all of the CompTIA exams. Okay. So our first thing to do is gather information. Okay, so what do I mean by that? Hey, my computer isn't working. That doesn't really give us a lot, does it? It doesn't really tell us what's going on with the computer. So we can ask more information. Does it happen at a certain time? When you say it's not working, is it a program that's not working or is it not powering on? And those responses that they give back to you, you can start formulating kind of different things that it could be. The biggest thing is just asking about changes. Are you, was there any construction in your room? Did they move something? Maybe the cleaners bumped a cable. I, no joke, had a teacher submit a help desk ticket one time and say, every time I move my mouse on my computer, it goes back to the center. It's like, did this start happening? Yes, it just started happening after last night. I walk into her classroom, and back then we had smartboards. There was a broom leaned up against her smartboard, okay? So even though the smartboard wasn't turned on, it's still an active surface, okay? So that basically it was like someone was just standing there holding the board in, and that's why her mouse kept moving over, okay? So asking those questions, is there something new? Is there a new program installed? Maybe the school district got a new website this year. Maybe an old one is cached, so that's why you're not seeing that new one. You could start formulating some of those things, okay? And that's called establishing a theory, okay? What could be the problem, okay? So, and this is not just in technology, this is kind of life in general. As a wedding photographer, I was always trying to think of these things ahead of time so that way I can make sure that, we were going into, let's say, I would always do first curl to last dance, so I was always there when the ladies were getting their hair done. So in my kit, I had bobby pins, I had stuff to apply fake nails, fake lashes, all that stuff to make sure, because I knew that there could potentially be a problem and I could help them and save the day and kind of build that trust ahead of time. Just like if we talked earlier about, class rules and whatnot, okay? What could potentially be the problem? I heard through the grapevine that there was an issue in a class, so then I started coming up with possible theories, Is it possible that the due date was different? Is it possible that, it said at a certain time something had to be turned? I'm already trying to come up with what these theories of a possible cause could be. I didn't just run to the teacher and say you're wrong, right? I'm still gathering that, because that is one wrong. The student could also be wrong. There was a miscommunication of some sort. Same thing with computer, okay? Could it be the program that's installed? Possibly. Could it be a network outage? Absolutely. Could it be a virus got installed and it's now causing that software to not load? So I'm coming up with these theories. I'm not just jumping right into things, okay? So we want to gather information, we want to establish our theory, and then we test our theory. Now, if you notice on this diagram, this is a process, okay? We're going to gather information, establish a theory, test your theory. Did it fix it? Yes or no? If yes, cool, move on. If no, go back, gather more information, establish a new theory, test that new theory, okay? I was doing this last night at ACCA with Chromebooks that weren't getting a new policy. So a couple things that we could do to fix it were the easiest thing, connects to a different network, hopefully it pulls a policy. Okay, that didn't work. Next thing, directly plug it into the network instead of relying on wireless. Okay, that didn't work. Now we're going to power wash the computer. Okay, so I'm going from things that'll take a couple seconds to sometimes 10, 15 minutes. If you have to reload a Chromebook from a factory default image on a flash drive, that's going to take 20 to 25 minutes. So again, we tried all the easy things first and then finished up with that last one. We still haven't solved the problem. So now I'm going back to this gathering information, doing research, submitting a help desk ticket to Google, those kind of things. I'm not just going right to test your theory. We have to take a step back and think about the totality of the situation, or the totality of the issue. From there, we're gonna do our action plan. What are the consequences? Does anything need approval? Like, do we have to buy something new? Constantly communicating with our users, over communicating. Like, as I was there, like every 10, 15 minutes, I was giving the director there an update on where we were at, okay? And then even this morning, I sent an email, kind of a summary of what we did last night. I'm over communicating to let them know that I'm still working on it. The worst feeling for a user is that their problem is not being worked on, or they don't feel like it's being worked on. You can pacify that user just by communicating with them, letting them know, hey, I'm still working on this. I need more time, okay? And by doing that, you're buying yourself, remember we talked yesterday about buying that trust with that user and being able to, if something happens in the future, you'll be able to kind of lean on the fact that you've had goodwill with them. So then we get to our wrap up. So we're going to make sure, follow up, hey, is everything okay? Maybe even a week later, hey, just wanted to make sure everything's okay. And then we're going to document our findings. Why is it important that we document what we found? Yeah. You've basically already created a how-to guide on how to fix this next time. And yes, you don't have to reinvent the wheel, but then you can delegate that to someone else, okay? So I came up with a possible solution for some of the Chromebooks to go to the student network. So I put that in the email. If you're still having issues today, here's something you can try, because we found this worked with some of the Chromebooks. So then when I get there to work on just the Lenovo's in this case that are giving us issues, they've already kind of taken care of any other ones that maybe we missed last night or weren't charged last night, okay? Boom, boom. Whew, we're moving. 146 out of 189. Okay, so configuring a ticket. I feel like this is something that first going into IT, a lot of people don't see value in. I've been in environments where I didn't have data to say that I needed more help. So I was working, burning the candle at both ends, working all these long hours until I established a help desk ticket, and then I could show that, hey, these are the help desk tickets that are coming in. This is why I don't have time to do it. And then I delegated views to all the principals in that case so they could see all the tickets that were coming in as well, so then they could advocate for me. Your ticketing system will also be your final step of documenting your findings. So now you're creating a searchable database for smartboard not working or interactive board not working, and then you could see all the tickets that came up and go find that, you go through and find those results and how to fix it quickly. So in your labs, you'll have to create a ticket and close a ticket. Seems pretty basic, but again, on the larger scale of things, that's why it's important, is to document everything that you do, so that way you can advocate for, let's say, you move to a place and then all the computers are junk, and you go and tell them that, and they're like, oh, you're a tech guy or gal, you just want nice stuff. But now I can give you documented findings of, hey, all of these warranties are expired, they're going to cost us more money, and we're slowing down productivity. I can make a business case for why we need to replace all of the computers, okay? So speaking of computers, pretty much anything that you work on in the technology environment that's more than like $5 or $10 is considered an asset, okay? And when we are organizing those things and keeping a database of them, it's asset management. So if you look on district-owned devices, like your Chromebooks probably have, look on the bottom of your Chromebooks, do they have asset tags on them? The PCs should. Yep. Yeah, so those are asset tags. So that tag can be scanned, and then it'll correlate with whatever the serial number is, so we can get all of our warranty information, when it was purchased or who it was assigned to. That's what asset management is. At more advanced IT help desks. When you call into the help desk, let's say you're working remote, you can give them that number, and then they can instantly remotely connect to your computer and help you and help troubleshoot things, okay? At more like small business or schools, universities, they don't tend to have the budget for that level of advanced system, but you can at least document like a MAC address so you can go to your DHCP server and see what IP they have and then remote desktop into it. We're not there yet, but you can kind of build your own solutions in order to do that as well, okay? So help desk tickets, yep. Yeah. Yep. And you guys do have, and I have no problem stopping, like, at all. But if you guys need it for review, you do have access to all the slides, and if you need to print those out, you can. They're in Google Classroom. So feel free to do that as well. Cool. Ticketing systems, so they help us identify issues. They also help us identify trends. So if we can see that, you know, Chromebooks are coming in for, you know, damaged or corrupt OS, we can see that there's maybe a bigger issue here, or wireless issues, or whatever it is. So that's why creating help desk tickets, like, it's not a barrier to your users, it's actually helping them. So when they come up to you and say, hey, I'm having this problem, your response needs to be, can you create a help desk ticket for it? If you can't fix it in a couple minutes, hey, can you create a help desk ticket? Or if you can't, if you have time to work on it right then, say, hey, I'm going to start working on this, but can you create a help desk ticket for me so I can document it? Yep, absolutely. Okay? So don't use your ticketing system as a wall. Use it as a way to help the users. Show them that it helps the users. Okay? So when it comes to ticketing systems, all of them are different, but these are kind of the common things that they're going to have. The user information will be preloaded, so they'll just log in and it'll be there. Symptoms, error message, recent changes. So they might leave this portion blank, so you might have to reach out to them and say, hey, can you give me more information? And then update the ticket with that information, okay? And after we're done here, I'll show you kind of an example of some changes that I asked for at ACA, and I'll show you kind of the help desk ticket and kind of how it works. A lot of these don't require you to go to a website to like update and stuff. You can do it via email. You can respond with an email and then it'll automatically add that information to the ticketing software, okay? Severity level. Where do you think the user is always going to put their severity level? Really high, right? Because it's messing with their day. They are going to say this is a big issue. So in a lot of help desk ticketing softwares, you're going to notice a reported level severity, then there will be another one for actual. They never see the actual. They don't see you updating and saying this is a low priority. But it kind of helps you if you're looking at, and especially if you're a boss, you're looking at all the issues and having what are your SLAs or service level agreements. So being down, you know, if something is going to be down for more than 24 hours and it's going to affect the entire building, that's really high severity. If it is, hey, I have this software that won't load and I'm going to use it next week, it's a little bit lower of a severity. Now, as that day gets closer, it might move up severity, but starting off right now, it's a pretty low severity level. Escalation. So escalation happens when you know, you have to pass this on to someone at a higher level. So if it's not something that I can fix, I then escalate that to Mr. Huffman. If Mr. Huffman can't fix it, he escalates it to usually like the network team over at TCCSA. But there's multiple levels. Now we're going to get a new help desk employee. His name's Cam, and he's phenomenal. Hopefully he's in here and he can talk to you guys. He used to work for me about 4 or 5 years ago, and he would be our tier 1 at that point. So tier 0 would be me fixing it, trying to fix it in my own lab. Tier 1 would be Cam. Tier 2 would then be Mr. Huffman. Tier 3 would be TCCSA. So it's this idea of, I can't fix it, I'm going to pass it on. And there's nothing wrong with you not being able to fix something. Sometimes you're just not given the resources to do so. Pass it on, work on something else that it is kind of within your level. Don't get basically hemmed up or drowned by trying to fix this issue that you shouldn't really even be able to fix anyway. Especially when you first start out at tier 1, there's going to be a lot of stuff that you have to escalate. Resolving issues. So having different statuses, this helps update the user as well. So if it just sits open and they don't see any change, they're going to get upset. But if you move it to in progress, they can see that you're at least working on it. Okay? So the next thing is solved. What's the difference between solved and closed? Why do you think we have 2 different ones? Yeah? Right. You're going to leave that open for a little while and then follow up with the user maybe a couple days later, and then move it to closed. Is that going to hurt your metrics? Yeah. I mean, a little bit, but at the end of the day, it's better than having a ticket reopened. So once you like dig into some of the like ITIL stuff or just how to manage IT and IT departments, you'll place different values on those. They're called KPIs or key performance indicators. And having a ticket reopened is worse than it taking just a day or two longer. See you later. Any questions about ticketing systems? No? So one of your projects that we're going to do once we get into some Linux stuff is going to be to install OS Ticket, which is an open source help desk ticketing system. So that's one of the things that you can choose as your server. Everybody's going to pick some type of Linux server that they're going to install and get working. It could be an imaging server, so if you want to be able to like quickly install the operating system on 10 machines, you'll be able to do that. It can be a web server. It can be any of those things. And you can do a ticketing system as one of yours as well. Make sense? Cool. Asset management. So earlier we talked about anything that's of like $5 or more. Every policy is different as far as needing or calling it or classifying it as an asset. But it can be information as well, information and infrastructure. So when we look at managing those different assets, district data or company data is an asset as well that you have to take into account of how you are going to manage that. So how are you going to back it up? How are you going to make it easily accessible? Those kind of things. That falls under that asset management as well. So we talked a little bit about it earlier, but inventory control, cost reduction, budgeting, and then finally when it leaves the institution, showing that you disposed of it. And in a good asset management tool, you'll have a place where you can upload like that certificate of disposal that we talked about that the recycler will give you. You can put that right in your asset management software so that if you're CFO or treasurer, your financial person, they have easy access to that, okay? And then yearly, like here we do a yearly audit actually twice a year, at the beginning of the year and at the end of the year for the things that are in our classroom. So for example, headphones, those are on our thing to audit and how many do we have? And then at the end we audit it again for, hey, so many were lost or stolen, okay? So that's part of that kind of asset management life cycle. So when it comes to buying new things, whether that's IT or like information products or software, this is an example of a procurement life cycle. Who knows what the word procurement means? What does it mean to procure something? Yeah? Adds on, okay. Or get something. If you are going to Taco Bell after you leave here to get food, you are procuring food. You are going, you've done your determine a need, your stomach's empty, it's growling. List of suppliers, so it could be Taco Bell, it could be the different Mexican places in town if you're like determined to get Mexican. From there, contract, maybe ordering would be your contract, saying, hey, I'm gonna buy this. Purchase order, I have the approval to buy this. Invoice and payment, so they're gonna send us invoice and say, hey, it's time to pay, and then they're gonna deliver it, and then audit, so we're gonna make sure everything showed up, okay? So let's go back to the beginning here for a technology example. Determine need. We need new laptops for our classroom, okay? Now I'm gonna go to a list of suppliers. So X-Tech, CDWG, Tiger Direct, Global GovEd, those are all different suppliers that we can buy Dell laptops from, okay? So from there, we're gonna put it out to bid. We're gonna say, this is the device that we need, give us your price. Because it's a public institution, and this is public tax dollars, so we can't just go to our buddy who owns, Hayden's Dell shop down the road, and he overcharges us. We have to put that out to bid, okay? From there, we have a contract that says, hey, we're gonna order these, for sure you guys won the bid, whatever, and then a purchase order. This is probably something that might be new for you. So the way that many institutions work, especially schools, all school systems work this way, is you get a purchase order. So I go to the treasurer and say, this is what I need, here are the bids, and they say, okay, you have the authorization to buy it. So a purchase order for the company is as good as cash, okay? So instead of me going and just taking a briefcase of cash to them to get my goods, I give them a PO that says, once this stuff is delivered, then we'll pay you, okay? So it's a little different than what you're used to of just going to Best Buy and buying a computer. What this does is it gives us a paper trail because then we can audit it and say everything is here and then we'll pay. So we're sending this invoice here, making sure everything shows up. I then send an email to the treasurer or the assistant treasurer that says, hey, this is okay to pay with our either a bill of lading or like a sheet that says everything that was delivered, a shipping, like a list of everything that was there. I'll sign off on it. They will then pay that company. Usually you'll hear terms like net 15, net 30, net 60, net 90. That means we have 30 days to pay that invoice, okay, before we go delinquent, and then there's other charges, okay? So does that make sense? I know purchase orders are a little bit different, but all that other stuff seems to be pretty standard. You guys understand that? Okay, cool. Inventory management. So these are some of the things that you have to, that you'll want to keep track of. And not everything's going to have a warranty or a license or something, but these are kind of the big categories that we have for our inventory management. Decommissioning, we talked about that yesterday. If it's obsolete, broken, worn out, no longer needed, and then we want to send it off for recycling so that way we can get our responsible recycling little tag that says we did the right thing by our for our environment. Don't forget you have 2 labs, create a ticket, close a ticket. So then documentation. So some key terms that you have to know for documentation. Remember, that's our last step, is to document our findings, okay? So we're going to talk about a few things, policies and procedure, and kind of what's the difference between those. They sound very similar. What is our standard operating procedure, or what's the SOP? Onboarding and offboarding. That last one, offboarding, when it comes to cybersecurity, is super, super important. So we'll talk about that here in a minute. So a policy is an establishment of rules set by an organization to address a particular problem or concern. So a policy is going to say, hey, like the dress code policy, this is what you guys need to wear, and then this is what action should be taken if that policy is not followed. That's different than a procedure, okay? A procedure would be kind of, this is our goal, and these are the steps that we're going to get to that goal. So our goal is for all of our students to look professional in a business casual type of dress code, if you will. So our procedure is going to say, when students come in, we're going to monitor it, or when they come into our classroom, give them the option, hey, do you have clothes that you can go change if need be? These are the steps that we're going to take to make that happen. But the policy says that you have to be within dress code. A procedure is how we're going to get there, okay? So our policy could be, before you have access to the internet, you have to sign an acceptable use policy. One has to be on file, okay? The procedure is every time a student comes in, we have them do final forms, and one of those final forms is they sign off that they have read that policy. So that's the procedure to get to our desired outcome. Do you guys see the difference between the two? Any more examples? Make sense? Good. And then a standard operating procedure, or an SOP, is if this happens, then we're going to do that. So if there is a fire drill, what are we going to do? What's the first thing that we do when we hear the fire drill? Wait for an announcement, right? So we're going to wait for an announcement to make sure that it is actually a fire alarm. From there, we're going to go out the door. I'm going to, part of my SOP, one of the things that I'm responsible for is counting you guys as you leave the building. Then once we get out there in our designated area, I'm going to count, make sure everybody made it out. Probably if it's a real fire, I'm going to pull up our class lists and, mark, who is not there. So instead of just a count, we can actually then have, when we have time, see who the people are that are missing and report those numbers up. And then once it's all clear, we can come back in the building, okay? So that is the standard operating procedure for a fire drill. You'll have this for new users. What is our standard operating procedure as far as what accounts need created? What is our standard operating procedure when someone leaves, okay? Which is our onboard, I think people are still taking notes. For onboarding and offboarding. When a new student comes in or a new staff member comes in, we need to do these 10 things, okay? This is our standard operating procedure on how we do things in this district, okay? Good to move on? Onboarding is when someone comes on. So this is a new user, comes to the building or comes to the organization. Offboarding is when they leave. Why do you think I mentioned that it's a cybersecurity issue, offboarding? Yeah?
Because if you don't offboard them, then their information is still within your company.
Yep. Their user accounts are still active. Or even offboarding to different departments. I've come on site to locations where the secretary has been in the district for 25 years, and she has access. She has more access than the superintendent has access to. Just because she's been around for so long, she's been moved around. She's been given more permissions. Nobody ever properly took those permissions away. And I really don't want to cross a secretary who's been there for 25 years and say, hey, you don't have access to this anymore, okay? Because secretaries and custodians are your best friends when it comes to IT, and sometimes the food service people if you're in a school. But again, I don't want to cross her, but that's because people before me didn't do their job to offboard them properly, okay? And we don't, and also offboarding is, hey, why did this person leave? Like, as the IT person, I don't need to know all the intricacies of what they did, but is that a cybersecurity threat, and they are going to try to, maliciously attack or try to do something to the organization that we need to be prepared for, okay? Documentation types, policy procedures. So the policy is the why and the what. The procedure is the who, the how, and the when, okay? So policy, why are we doing and what are we doing? Procedure is how are we going to do it, who does this apply to, and when is it going to happen, okay? So our standard operating procedure, like I talked about, some of the common things that you'll have is the purpose and the scope, then step-by-step instructions on what to do, any requirements. So like for me, having keys to get back in the building is probably a requirement, right? Because we kind of want to make it back inside. And then what are some common issues or solutions? I was first introduced to SOP at Geek Squad. Everything that you do at Geek Squad has an SOP on how you're supposed to do it. SOPs help with scaling. It helps with bringing more people on. So spending the time to do these things can help when you want to grow the organization, when you want to get that extra help that the help desk ticketing system documented that you need. SOPs can help you bring that person up to speed much faster. So buildings, institutions, schools, whatever it might be, we have what's called regulatory compliance. Who knows what regulatory compliance means? What's an example of it, yeah? Absolutely. So my mom does regulatory affairs for Henkel Consumer Adhesives. So what that means is all like MSDS sheets or material safety data sheets. They're for any chemicals that are in a business or organization, and it says, hey, what happens if this gets in your eyes or is inhaled or you touch it? It tells us like what that chemical layout is, so that way you're not chugging water when you should be, or inducing vomiting when you should be trying to chug water and stuff like that. So all of our MSDS sheets we have access to. It's on an online portal. But even for the 3D printer, like one of the reasons that we haven't used the resin printer yet is because I don't have the MSDS sheets for that chemical. So we can't safely use it. So because if something happened to you guys and we didn't know how to do it, I'm liable for that. The school is liable for that if you get injured. So again, MSDS sheets are just one example of a regulatory compliance that we have to abide by. There's OSHA, so how you use ladders, safe work environments. There are ODE, has regulatory things that we have to do at a certain time, like with special needs and making sure that we're addressing all of the concerns there. So depending on the industry that you work in, you're going to have different needs. So if you're in healthcare, you're going to have a totally different, you're going to deal with HIPAA compliance and making sure that health information is, has to stay secure. Here in schools, we have FERPA, so making sure that your educational records stay secure. That's all part of our regulatory requirements. If you notice on the student Wi-Fi, you probably had to accept that like you wouldn't do any hacking or anything like that. So we have to do what's called CIPA and COPA compliance, which says, hey, we're going to keep your identity safe online, and then also we're not going to let you see things that would be considered bad, I guess. So like everything from hacking websites to pornographic materials, even games can sometimes be put under that. That's why we have those blocks in place. Games is more just to kind of keep you guys, on task. But some of those games could have an online chat component that could result in a data leak. Okay. Another thing is our password policy. We talked about this yesterday by having too long of a password policy. Length is super important, is actually more important than complexity. If you look at any of the research or the tests that have been done, every time a letter or a number is added on to the requirement, it exponentially goes up. So like a 4-digit password could be seconds. 6 digits could be minutes, and so on and so forth, hours, days, years, trillions of years, whatever. So we'll get to a point where we'll do like a password lab where you guys will kind of set that for, kind of set it for your users. So for example, the fact that you guys use lunch codes for your, and just numbers for your, for like all of your passwords, those can very easily be brute forced within probably a day or two if we were doing like a bunch of them, if not sooner, depending on the hardware that we had. If we had a computer with a really good video card, it could be within hours.
I mean, you can mathematically map this out, because, it's just the longer the password, the more variability, and then the more characters you're allowed to use, the more complex the password.
Correct. Yep, absolutely. And there's actually, and I can pull the chart up if you like. You can actually see the chart and how long it takes for different passwords and whatnot. So security policies. So these are some of the kind of the common ones that need to be in place. Backup policy. Why do you think it's important to have a backup policy? Okay, that's one reason. What is one of the worst types of malware that you can get? Ransomware. Okay, ransomware is going to hold your data hostage. So for hospitals, okay, where it's literally a life or death situation, do you think they have good backups that they can restore very quickly? Probably. Small businesses, probably not as much, right? If they lose that data, and a lot more of this data is going to the cloud. Not that it's protected on the cloud, but we have less of a requirement here at the district level or the building level or business level. Physical security policy, pretty self-explanatory. Acceptable use policy, you guys all signed one of those, right? Or you wouldn't be able to have access to a computer. BYOD, what does that mean? Bring your own device. So you guys are allowed to bring your phones, right? You're allowed to use them here on the network, right? That's because we have a BYOD policy, okay? And that's something that they've looked at possibly getting rid of, but I have been fighting that good fight for you guys to make sure we keep those here. Network diagrams. Why do you think it's good to have network diagrams? So you know where everything is, or if something happens to you, that other people can kind of pick up and there's no downtime. Also, it helps with troubleshooting. Is this a logical or a physical diagram? Logical, right? Not, these things aren't necessarily, you know, in one location, or they don't have to be in one location. This is just logically how everything is connected. Actually, this part up here would be kind of logical, where this might be a little bit more physical because it's an actual floor plan as the background. But this part up here is just kind of logically like, where's it set? Cool. 8 more. So paperwork, we talked about those. NDA, what is a non-disclosure agreement? Yep.
It means that, like, if you agree to not, like, talk about it or like, post about it or anything, like, it has to be confidential, whatever it is you agreed to.
Absolutely. So every time that I've formed a business with somebody else, we always sign non-disclosure agreements and non-compete agreements. Means we can't just take ideas that we came up with together and just go start our own side hustle and start a side company. Okay, you see this a lot more with programming, but depending on like where you go and work, like if you go work for a 3-letter organization, NSA, CIA, FBI, any of those, you're definitely going to have non-disclosure agreements because you're working on things that can't get out to the public. Also, there's NDAs as part of, like, even when I worked at Panasonic, because there's corporate espionage that goes on where other camera companies wanted to know what we were doing. So we were under NDA that we couldn't talk about it, okay? Because as tech reps, we would have probably sometimes, 3-4 weeks ahead, other times months ahead, other times just minutes ahead of announcements, and we couldn't talk about it with our dealers or any of that because we didn't want that to get out, so that way another company couldn't move up their announcement timeline to, jump the shark or beat us to the punch. Okay. Onboarding and offboarding, just make sure you have kind of a checklist of what you need to do, but this would fall under your what? What would that checklist fall under that we talked about today? What's that? Not necessarily tickets. So a checklist of what we need to do to onboard and offboard a employee. What would that fall under? It would be a procedure, but what is the overarching document? It's a 3-letter word. It is our, starts with an S. It's our SOP. What is our SOP for onboarding and offboarding? Well, here's a fancy checklist that tells us everything that we need to do. This is the procedure to do so, okay? training. Blah, 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 blah. So one of the things that would be on that onboarding is a list of training that they need to do. Also for security, how to log into their accounts, how to access like a knowledge base of how to kind of fix it yourself if you don't want to wait for IT. Also talking about security. Obviously, don't click on phishing websites. How to identify phishing, email and stuff like that. Everybody know what phishing is? Anybody not know what phishing is? It's fine if you don't. Okay. Malicious websites, stuff like that. So just best practices for security. And then when we offboard them, we want to make sure that we're disabling their email or any of their login accounts. We're forwarding any email or voicemail to someone else that's responsible for either that task, whether that's be their boss, or a new employee. Collect any physical devices that they have. So if they have a work laptop or a work phone, we want to make sure we get that collect. And then any access codes. So they might have an access code to the building, or they might have like a group code that then has to be changed, okay? And most of the time you're not gonna like change the wireless password, but you might put on a monitor that if this device connects to the network, then send out like a notification, okay? Cool. And that's all we have for today. We got through module 2. How does it feel? Awesome sauce, okay? And again,